Right, so here's a video on how to reset an Ibanez base to use the Line 6 Relay G10 wireless connector. Nice little unit, but Ibanez bases, the socket is recessed too far down a hole, and this fella can't plug in far enough to connect. So we need to get the whole of the pin in, and this little activator pin here has to be pushed down to turn the unit on. We can't do that. So that's one issue. That's just mechanical. That's easy enough. The other issue is with the G10, see there's three connectors here. Normally, an ordinary jack, those two connectors are joined. So when you plug it into the instrument, it joins two contact points inside the socket, and that turns the power of the instrument on. Now, with the Relay G10, because it needs to be able to charge in its charge station, this has been divided into two. So we have the tip, the sleeve, and the ring. And if the G10 transmitter detects a voltage in one direction across here, it lets it pass through, which turns your instrument on. But if it detects a voltage in the other direction, it assumes it's in the charger, and so it won't establish a Wi-Fi connection, and it's going to accept current to charge the internal battery. Unfortunately for me, all three of my bases, the polarity is the wrong way around. So we're going to have to do some rewiring on the jack. Now, just for comparison, here's one that I prepared earlier. This is my SRF 705 fretless, and you can see I've reset that jack position so it's not nearly as deep in the drilled hole. So when I take the G10 and insert it, it does in fact go all the way down, activates the on switch, and that unit works really nicely now. So there's two things that I had to do. I had to reset the position of the jack so that it's not so far down the hole, so it sticks out a bit, and I had to do some rewiring. Let's step through those exercises on the other base, which I haven't done yet, which is the SR1805. Okay, here's the inside of the SR1805 with the back plate removed. That's the jack that we need to mess with. Mechanically, it's not that hard. We want to take off this nut, put some spacing things on the other end, reinsert the jack, put the nut back on, so that the whole jack doesn't protrude so far into this cavity here, and it's actually further out that way. Unfortunately, to do that, I've got to unsolder these wires. So I suggest you take a photo of things before you start anything so that you can reconnect wires where they ought to go. The other thing that we do need to do is we need to reverse the polarity of the power on the ring and sleeve. The tip connector, that's the active signal. We want to leave that as it is. The other two, we just want to change them around. So the first thing I'm going to do here is remove this heat shrink from the solder points, solder connections, so that I can actually get to the solder, because I'm going to have to heat that solder and melt it so that I can disconnect the wires. So I suggest a really sharp knife. Go carefully because you don't want to cut the stuff underneath. I'm just going to pause the video now and do this because it's easier with two hands, but you see what I've got to do. That black heat shrink, I want to remove all of that. So there's the heat shrink removed from one of the solder points, and I've got to go and do the other two. I'm going to have to remove all of these wires so that the jack can be taken completely out through the socket here, and then I need to put some spacers on it before I put it back in. So I've removed the heat shrink off two of these, and the way that I find easiest is to put a slit up the side of the heat shrink. Be careful, you don't want to cut through the original insulation on the rest of the wire. But put a slit up the side of the heat sink. Then grab a bit of it with the pliers and then just tug it out. This one's not coming so easily, but you get the idea. Okay, I've got the heat shrink off all three of the solder joints here. So we want to think carefully about what we're going to do, because we need to get these wires back the correct way. I'm going to have to unsolder them, remove the wires so that I can take the jack here out, put the spacers on, put the jack back in, then I'm going to have to resolder the wires. I'm going to make sure I get the wires in the right place. If you look from the side, you'll notice that the three connectors on this jack are different lengths. The longest one is the sleeve, the shortest one is for the tip, and the middle length one is for the ring. Now, have I just said that the wrong way around? Here's the jack, it's going to come in here. The lengths here reflect the order of the connectors here. So I'm going to say actually that one. No, I better check this. Right, here's a good diagram that I found on Google. This is what I did before, so I'm just going to follow this. See, the three connectors here are different lengths, and the shortest one belongs with the tip, and the middle length one belongs with the ring, and the longest one belongs with the sleeve. So the length here matches the order of these. So I'm going to go with that. I'm pretty sure that's what I did last time with the fretless bass, so I'll do the same here. So translating that information over, we're in the back of the SR1805 again here. If you look side on from the jack, the white cable there is on the shortest connector, so that's going to be the tip. That one has to stay there. When I rewire this, the signal has to still go to the tip. Here's the ring, and here's the sleeve at the back, the longest one. Right. So when I rewire this, I want to put that wire on the ring and this wire back on the sleeve. Now on the fretless, all three wires were different colours, so that was nice. Here, I've got two black wires for the power, and I need to reverse them. So before I unsolder them, I'm going to mark one of them so that I know which is which. Actually, before I do that, all these cables have been nicely wound up and cable tied together to keep it all neat, and I'm finding I haven't really got enough length to work with, so I'm going to cut that cable tie there so that it releases the wires. Okay, that turned out to be a good move because I've got plenty of length to work with here now, and also it's become quite clear. That cable that's currently on the ring connector comes direct from the battery. So the cable direct from the battery I want to put on the sleeve connector. Right, so that's enough information now. I know how to rewire this. The white cable will go back on the tip where it is. The battery connector will go on a sleeve. The other black one will go on the ring. Easy fixed. So now I'm going to get a soldering iron, heat up that solder so I can disconnect these wires. Right, while my soldering iron's heating up, I'll just explain something here. I'm not particularly expert solderer, and I definitely need two hands to do it. So I'm not going to video that, but see on here I've got quite a volume of solder, which is fine, that makes for a nice joint. But what I really want is for the solder to come away so that I've got clean terminals to solder back onto, and I can get to the holes to poke the wire through and then solder it in. So a trick that I got showed by the guy at JCar was this solder wick or desoldering wick. It's copper braid, and what you do is you put it down on the solder, and then you put your soldering iron down on top of it and heat it up. The solder melts, and the liquid solder then runs up into the braid. So you actually remove the solder, and then you cut that piece of wick off and do it again. Pull the wires apart, and it cleans up the joint quite nicely, so you don't have loads and loads of solder there, because you don't want, for example, solder. You don't want there to be so much solder that, you know, it kind of leaks across and connects to another connector or something. So just to keep things clean, solder wick or desoldering wick. This is the brand I'm using, and it works like magic. It's great. Okay, so I've unsoldered the first joint there, which is this white wire here. I just put the desoldering wick down on there, put the soldering iron on top of that, and you can see all the solders run up into the wick, which is great. Okay, I've desoldered the other two joints. So that bit of wick at the end with the solder, you just snip that off with a pair of scissors, and I'll go and clean up those terminals a bit so there's a bit less solder floating around, and then we'll get on to the mechanical aspects of the project. So here we are. I've got all three wires disconnected, and that desoldering wick is really great. Those terminal points are all reasonably clean, as in I can see the holes in the terminal, so when I come to reconnect the wires, I'm going to be able to poke the wire through the hole and then apply a bit of solder and get a nice joint there. So now onto the mechanical stuff. I've got to unscrew this nut that'll come right off, and then I can take the jack out. So I've loosened that off with pliers first. I was holding it quite snugly. Just screw that all the way off here. And I've dropped it in. There it is. And the jack itself, hopefully, is going to just come out of that hole. And here it comes. Yep. Cool. So the issue here is the jack as it stands will go right into the hole up to that point. I don't want it to go that far in the hole. So I'm going to put some extra things on here before I put it back into the hole, so it's not going to go back into the hole so far. Right, so what I need is something that I could put on here so that this won't go as far into the hole. That was an interesting challenge. I went to Bunnings. All the washers that I found that were big enough to go around here, they were too wide to actually fit in the hole. So washers were out, and I thought, you know, if I can get another one of these nuts, I can put that on there, and then I can actually adjust how far it is. But I could not find a nut the right size. Went to JK Electronics. They said, no, we don't sell nuts. And I said, I'm happy to buy something with nuts on it. So we went looking for a similar jack, didn't find anything. So basically the sales rep gave up. I kept rummaging through all of their components, and what I ended up finding was switches with nuts so that you can mount the switch behind a panel and, you know, fix it in onto the panel. And lo and behold, these nuts were just the right diameter and the right thread pattern to fit onto here. The other thing I found, because I wasn't sure exactly what was going to work best, was a little waterproof switch cover, which is the kind of thing that would go over here and screw onto there, but just be a waterproof cover for the switch. And so what I actually did on the fretlets was I cut off this rubber piece, and I was just left with a nice nut there. So I'm going to go ahead and cut this rubber off, and then I'll come back and show you what I'm doing with it. So to cut the rubber off, I found it useful to put it over something and stretch it, and then you can just run the knife around the edge there, like that. So I'll go ahead and finish. So here I am with my TRS jack. The washer that came with it, I'm just going to put that on there just to fill a bit of space and be nice and dark. And no, which way I think I put it that way because I wanted this edge to be taking the load. Did I? No. The other thing I did, I actually ran round the edge there with a knife to take that edge off, just so it wasn't quite so large diameter, so it could fit into the hole a bit more easily. So I've got to do that first. Okay, so I'm partly through this. I'm not sure if you can quite see, there's a little bit of a lip on there, and round here I've actually just cut that off so that the whole thing is slightly smaller diameter, fits in the hole a bit better. So I'll just finish that off. Okay, so I've trimmed that edge lip off and I've put that nut onto here, and I'm going to basically wind it all the way down. Now if I want the jack further out, I can reset this nut just here, and I can do that by opening things up, pushing the jack through the hole with the wire still on it, turning the nut a bit, putting it back in, tightening it up. So I don't need to unsolder and resolder stuff to adjust stuff. Whereas if I'd used washers, then to change the jack depth setting, I would need to go through the whole unsoldering, resoldering business, which is a bit of a pain. So I'm quite glad that I stumbled across this way of doing things. So that's on there. Right, so with the jack out, you can see from the outside, here's the hole that I need to put the jack into, and you can see that wooden edge down there. And I just need the jack to not go in so far. So I've put on this extra nut. In fact, for this guitar I've chosen to do a little bit different. And I'll put a second nut down there first so that I can screw this one to wherever I want it and then lock it in that position with that small nut. And then it's just going to be easier to adjust and have things all secure. Right. So I'm just going to tighten that up, for which I'll need 2 hands, so I'll turn the video off. Okay, and now I'm going to insert this jack back into the hole, and you can see because of those extra things I've put on there, it's not going to go in as far, which is going to achieve exactly what we want. See, now the jack here is quite visible from the outside, and if I put the G10 transmitter in there, it actually goes all the way into the jack. Right? These edges don't get in the way because the jack's further out. So let's put the instrument down. Here's the jack from the inside, and you can see it clearly doesn't come through as far. So now I've got to put on a couple of nuts and fasten that there, and then resolder everything up, and that should be all hunky-dory. Okay, so here's the original nut back on, which I'm going to tighten up with a pair of pliers, and then a second nut, which I'll tighten down onto that to lock it in position, and then that jack will be very secure. So there we are. I've tightened down the original nut with a pair of pliers, and then this second nut I've just done, I don't know, about a quarter turn, well just finger tight, and then another quarter turn or so with pliers just to put force against that nut, so it's going to lock it there, so it's not going to come undone in a hurry. Let's flip the instrument over and try putting the Relay G10 in. And it plugs in all the way, quite snugly. There's a little bit of room to move. So yeah, and the lights come on indicating that it has activated the switch on the edge there. So that's going to work. Now I just need to resolder everything. So let's go back and look at that. The short connector is the tip. That was the active signal, so the white wire has to go on there. The medium connector is the ring and the long connector is the sleeve, and I want to reverse the polarity to what I had before. So previously this battery connector was on the ring terminal, but now I want to put it onto the sleeve terminal. So I'm going to go ahead and solder those three up. I think I probably should put some heat shrink on too. So I've got some heat shrink stuff here, so I'll just cut short lengths of that I can slip over the wire, and then after the soldering's done, then I can slip the heat shrink down, brush it with a bit of flame, and it'll just tighten up nicely and insulate that in case there's any stray wires floating around in there, which there shouldn't be, but just makes it nice and tidy. So here's my three little pieces of heat shrink that I've cut. So put them over the wire first, because once you've soldered the wire on, you can't get this around it. Right, so that's going to go on there. Two hands would be nice. So I'm just going to pull that right back up the wire, keep it out the way. Once I solder that on, then afterwards, or when I've soldered all three of them on, then I can slide this back down over the solder joint, over the terminal, brush a bit of flame over it, it'll shrink down and keep that joint nicely insulated. Right, so here's my three wires soldered back on, the white one onto the tip and the two black ones, but notice that I've got the battery power now on the sleeve connector instead of the ring connector. So now I'm going to slide these heat shrink things down over the terminals, and might need two hands, so I'll turn the video off for it, but I'll slide them down over and then we'll just brush them with a bit of flame and they'll shrink and stick in position. Right, so I've got my little blowtorch here and I'm just going to gently brush the heat shrink, and true to name, when it gets hot it shrinks. I'm trying to be careful not to make anything else too hot, so you really just want to brush it gently. And you don't even necessarily have to shrink it to full shrinkage, but just so that it kind of sticks on there nicely. And I reckon that's good enough. It's not going to go anywhere. So I'm going to let that cool. Since I've got it open, I'm going to put in a fresh battery, pack all the wires down, put the back plate on, and then we'll give it a whirl, see if it actually works. So here we are for the big test. Here's the G10 base unit. You can see the ring LED is pulsating, which means it hasn't got a Wi-Fi connection. Now, two tests here. One, does it fit? And we know the answer to that is yes, because we tried that before. And voila, we have sound. So we have a steady rim LED here, which means we've got a good Wi-Fi connection, solid green light, and indeed I can get lovely sound coming through my nice E-Namp Hartke speakers. And so, success. That is how you get a Relay G10, Line 6 Relay G10 wireless unit to work with an Ibanez base. I guess I should point out that I'm no electronics guru. This has been working on my fretless for several days. I haven't had any issues, but if it cooks your electronics, I'm sorry, but I don't take any responsibility. So your mileage may vary, but it's working for me. Enjoy.